In this video, we're going to take a look at one of the most exciting stacks I've seen in a long while. We're going to be looking at tRPC with Next.js, TypeScript, and Prisma. So if you're watching this video, I'm going to assume you have a rough idea of what tRPC is. But before we get started, let's have a look at some of the reasons that you should be using tRPC. So firstly, this is the biggest thing for me. It makes making end-to-end type-safe APIs fun and most importantly, easy. It's going to give you a deeper understanding of Next.js, and we're going to get into that in this video. And I don't often make predictions, but I'm going to make one here, and I think this is going to be a very popular framework. And so if you start learning this now, you're going to be ahead of the curve. So one thing that I think a lot of people find confusing is the path that your request is going to take. So when we make a request from the user interface, we're going to make it to this /API/tRPC endpoint. And then the request is going to go through, we're going to build out context, then it's going to hit our app router, and then the request is going to come back to the user. And we're going to be able to visualize this whole request cycle here, and we're going to get a deeper understanding of this whole request cycle here as we build out this application. So the technologies we're going to use, of course, we're going to be using tRPC, we're going to be using TypeScript, we're going to be using Prisma, and I'm going to be using Postgres, but you could use any database that you like. Prisma is going to support MongoDB, MySQL, and SQLite. We're going to use Zod for schema validation, and this is built into tRPC. And Zod is going to do a lot of heavy lifting here, as you'll see. And then finally, we're going to use NodeMailer because one of the features we're going to build is a one-time password for signing in. So what are the features that we're going to build? We're going to be able to register users. We're going to be able to log in with that one-time password. We're going to be able to create a post, we're going to be able to view a post, and then we're going to be able to list some posts. So this is a pretty standard CRUD application, and you're going to see how easy it is to build out all these features with tRPC, and we're going to get full type safety along the way. Before we go any further, I just want to expand on this, what it means to make end-to-end type-safe APIs. So tRPC is going to do a lot of heavy lifting in terms of interface building for you. So you're not really going to have to write much TypeScript. All the code that you're writing is pretty much JavaScript, and then you're going to get a lot of the benefits that TypeScript offers for free. So what will you learn? You're going to learn enough about tRPC to be productive. You're going to learn about using Next.js as a monorepo, and I think this is a topic that a lot of new developers to Next.js find really confusing. But as a result of watching this video, you're going to get a really deep understanding of what this actually means and the lifecycle of your requests. You're going to learn some TypeScript, but as I mentioned, tRPC is going to do a lot of the heavy lifting for you when it comes to generating types. And you're going to learn about a one-time password login flow. So what will you need to follow along? You're going to need to start up a running instance of a database. We're going to use Prisma, and as I mentioned before, you can use Postgres, Mongo, SQLite, or MySQL. I'm going to be using Postgres, and I have a running instance of Postgres in a Docker container here. So you can see that I can just start and stop my Postgres instance here. I'll leave a link below to a repository called Awesome Docker Compose, and that's going to allow you to start up a Postgres instance really quickly with a Docker Compose command. And this is the video structure that we're going to follow. So first off, we're going to do a demo, and then we're going to do a code walkthrough. I think the code walkthrough is really important because some concepts that we're going to go through here are quite confusing. And if you're seeing them for the first time as we build it out, then they're going to be even more confusing. And then we're going to get into building out our application. So we're going to build out all these features. And if we have a look at the steps we need to build out each one of these features, you can see as we progress along, we're going to get to a point where we only need to perform 2 or 3 steps to add a feature to our application. And this highlights the true power of tRPC. Some developers have said the bootstrapping part of the application can be a little bit confusing and tedious, but once you get through that, adding features to your application is extremely easy. Let's come over to the browser and we're going to be able to have a look at what we're going to be building. So we have a login screen here. It's very simple. I'm not going to do any styling in this application because I want you to be able to take it and build it into your own application. So we can register here, and I'm going to register with the email of t2@t.com. I've already registered T. And then I'm going to register with the name Tom. Let's register an account. And now we can log in, and I'm going to log in with t2@t.com. I'm going to click the login button here. And if we come over to the terminal, we're going to get this message here that says message sent, and we have an ID of a message. And we're going to get this URL here. So let's click on this. And this is the preview of an email. So we can click this link here. We're going to go back to our application and now we're logged in. So now that we're logged in, we can create a post. My post body. Let's create the post and we go to this post. If we go to our post URL, you can see that we're just going to get a simple list of posts here and we can click on one and we're going to go to that post. Let's inspect and have a look at one of the network requests. So I'm going to click on a post. And you can see that this request here is going to localhost port 3000 /API/tRPC/post.singlePost. Let's go have a look at the API handler for this path. So if you're familiar with Next, you'll know that Next has a pages folder. And inside of the pages folder, there's a folder called API. And in here, we're going to have a folder called tRPC. And then we're going to have a tRPC.ts. And we have these brackets here. Let's have a look at this request again. So we have the API portion. And then we have /tRPC. And then we have this post.singlePost here. And what this brackets here is going to refer to a dynamic route. So anything that goes to /API/tRPC is going to get handled by this function here. This function is going to return a tRPC next, which comes from tRP server. And we're going to create a next API handler. And inside of our API handler, the first part is our routers. The second part is our context. And then we have an error handler here. Let's dive into our routers and have a look at those. And this is where the magic happens for tRPC. So we have our app router here, and this is going to be the centralized point for all of our resolvers. So we have this create router function, and then we have this merge for users, and then we're going to merge in our user routes, and then we have a merge for posts, and we're going to merge in our post routes. Let's have a quick look at create router. So create router is just a function that returns router, which comes from tRPC server. And you'll notice the tRPC package is split into @tRPC/server, and then there's another package called /client. So this is going to return a router, and we're going to use super.json as the transformer. And the router is going to take a generic, and the generic is going to hold our context. So before we dive into context, let's come back to app router, and we can have a look at our users router here. And you'll notice that we have this users dot, and then if we go into user router, we have our mutations, and then we have a query, and we have a couple of queries here. So let's have a look at this me query. So the API endpoint for me is going to be /API/tRPC/users dot, and then me. And then this resolver here is going to resolve that query. Me is simply going to get user out of context, and then it's just going to return the user that sits in context. We can also optionally throw an error here if we don't find the user in context. So let's go back to our tRPC API handler, and let's have a look now at context. So we have this simple function here that's going to build context. We're going to try and get the user from cookies. And this function here is either going to return a context user or it's going to return null. And we have our context user here. So when we build context, we're going to return our request, our response, and these are Next API requests and responses. We're going to add our user, which is either null or context user. And we're also going to add Prisma. You don't need to add Prisma to your context. You could just import it into each route, but I think it's nicer to pass it around with context. So if we go back to our user route here, you can see that in our resolver, we get access to context here, and now we can start using bits of context. So if we go up to verify login, you can see that we're trying to get the token out by calling context.prisma.login token, and then we're going to call a function on this Prisma model. So that is the general flow of how tRPC works inside of Next.js. If you don't understand that yet, don't worry, it's going to become more clear as we build out these features. So the next thing to look at is how does tRPC work on the client? Let's go over to our pages here. And the first page we'll look at is _app. And if you're familiar with Next.js at all, this will look familiar to you. So we're going to build out my app. We're going to make a request to users.me with trpc.useQuery. And then we're going to create a user context provider. And this is just normal React context here. And this just means that we can use the user from context throughout our application. If we scroll down, we'll see what's being exported from _app. And we're going to export this higher order function called with tRPC. And with tRPC is going to be executed with my app. And with tRPC takes an object of config. So you can see here that config is a function. And then from that function, we're just going to return an object. So inside of this object, we have our query client config. We have some headers that we want to add to our requests. We have our transformer, and again, we're using super JSON. And we have our links. So links in tRPC are really interesting, and they work a lot like links in Apollo server if you're familiar with that. You don't have to use links here. We can comment that out, and we just have this URL string here. And we could just put our URL, but using links is going to give us some extra features. For example, we have this logger link here, and if we go back to our client and we have a look in the console, you can see that we have all our requests logged out here, and this is going to be really handy for debugging. And then secondly, we have our HTTP batch link. And again, if you're familiar with Apollo, you will be familiar with query batching. So this just means that we can send a bunch of queries that would be sent at the same time in a single batch to the server, and this is going to give you a significant performance boost. So if we go to our index page here, you can see that we're using user from context, and then we're simply just going to link to create a post if we have a user logged in. If we don't have a user logged in, we're just going to render our login form. Let's have a look at our login form. The interesting parts to note on the login form is this tRPC.useMutation. And tRPC here on the client comes from a utility that we're going to build out. And this is just going to return create React query hooks. And this just means that we can use mutation and useQuery. Then we get this mutate function here, and we're going to be able to call mutate with our parameters. UseMutation and useQuery also come with an options object that we can pass in. So we can say on success, and this is going to get called when our mutation gets called successfully. We have on settled, and this is going to be equivalent to a finally block in a try catch block, or we have on error. So before we get started, there is a file inside of the repository, which you'll find a link to in the description below. And this file is called notes.md, and notes.md is going to have a bunch of commands that you can use throughout the tutorial. So the first command I'm going to use is this yarn create next app to bootstrap our application. And I'm just going to call mine tRPC tutorial, and then we're going to use the TypeScript flag, and this is going to configure TypeScript for us. So once Next has finished bootstrapping the application, I'm going to cd into tRPC tutorial, and then I'm going to open this in a new VS Code window with code. So the first thing we're going to do is we're going to go into our tsconfig file here, and I'm going to find strict mode, and I'm just going to make sure this is set to true. The second thing I'm going to do is I'm going to open up my pages. I'm going to open up API, and then I'm just going to delete hello.ts because we're not going to be needing that. Next, I'm going to open up notes, and I'm going to copy this install command. And then in the terminal, I'm just going to paste that in. The next thing I'm going to do is to install the development dependencies. And I'm not going to initialize Prisma yet. I just want to stick to pure tRPC just so I don't muddy the waters. So inside of my root directory here, I'm just going to create a new folder, and I'm going to call this src. And then I'm going to move all of my source code into src. And this is just going to make it a little bit easier to see what I'm working with. You don't have to do this. This is optional. Next.js supports it, but it will make your application easier to use and develop on later down the track. So inside of src directory now, I have API, pages, public, and my styles. Inside of styles, I'm going to open up global.css, and I'm going to paste in some styles here. I'm not going to go through what these do. Basically, they just make the application easier to see in the video. If you want to copy these styles in, you'll be able to find the link to the finished repository in the description below. But I don't recommend that you do. I recommend that you use a component library and build out the application to be something that you've created yourself. Next in src, I'm going to create a folder, and I'm going to call this utils. And then inside of utils, I'm going to create a new file, and I'm going to call this tRPC.ts. And inside of here, we want to export a tRPC function that we can use on the client. So I'm going to import from at tRPC/client. So we want to import from at tRPC/React. And I want to import create React query hooks. Then I want to export const tRPC equals create React query hooks. And I just want to execute that function. We have a generic here and we need to put our app router inside of this generic, but we don't have that yet. So let's go build that. So I'm just going to add a to-do here, add app router as generic. So the next thing I'm going to do is come over to pages, and inside of underscore app.tsx, we're going to configure tRPC. So instead of exporting default my app, I'm going to export default with tRPC, and this comes from tRPC/next. And again, this is going to take our app router as a generic. So I'm just going to add that same to do add app router to generic. But for now, I'm just going to add a object, and then I'm going to have config, and config is going to get our context, and context is going to be of type undefined at the moment because we don't actually know what context is because we haven't built out our app router. And then config needs to return an object. So let's define our URL. So I'm going to say const URL is equal to process.env.next public Vercel URL. And this is going to get defined if you deploy to Vercel, which I recommend that you do. And if this is defined, then we're going to have HTTP, and this is going to be HTTPS. Then we're going to get this process.env.nextPublicVercel URL /API/tRPC. Otherwise, it's going to be HTTP localhost port 3000 /API/tRPC. Okay, so we could just return URL here, and this is going to make tRPC happy, but we want to define some links like our logger link and our batch link. You don't have to do this, but it's going to make your application faster and it's going to make it easier to debug. So then say const links is equal to, the order of these links in this array is important. You need to make sure that you either return a HTTP link or HTTP batch link after the logger link. We're going to call logger link and we're going to execute that. Logger link is going to come from at tRPC/client/links/logger link. And if you have a look, you can see that we get a few different links here. We get a WebSocket link, a split link, logger link, HTTP link, and a HTTP batch link. So for now, we just want the logger link. And let's also get the batch link so we can use that as well. Then we can define our HTTP batch link, execute that, and this takes a couple of options. The first one is going to be the max batch size, and I'm just going to set that to 10. That's a reasonable batch size. And then the next property is going to be the URL, which is of course going to be our URL defined up here. So instead of returning our URL from config, I'm going to return our links. Next, I'm going to define query client config, and I'm going to set some default options. And then these default options are going to be for queries. And then I'm going to set the stale time to 60. And if we have a look at what stale time does, it says the time in milliseconds after data is considered stale. If set to infinity, the data will never be considered stale. So you can adjust this number here, or you can toggle it on each individual query. These are just default options. Next, we're going to set some headers. And headers is just a function again. And we're going to say if context.request, then we're going to return context.rec.headers. And this means that we're going to add our headers to the request into the server. And so we're going to be able to get our cookies out of this headers here. I'm going to also set a header called xSSR, and I'm going to set this to 1. And this just means that the request is done on the server. If context.request doesn't exist, then we're just going to return an empty object. Under links, I'm going to set the transformer to super JSON. And super JSON is going to mean that we can use different things like native dates, native maps, and sets. I need to import super JSON from super JSON. Okay, so this is it for our config. There's one other property that you can set down here, and this is going to be SSR, and I'm going to set this to false. The reason I'm going to set this to false is because we want to be able to see every single request that our client is making. If we set SSR to true, our client is going to make requests on the server, and we're not going to be able to see those requests in the network tab. If you want to be able to use SSR in your application, everything we do here is going to work, but I would really consider whether you need SSR or whether it's just something that you would like to have. Whether you use SSR or not, your application is going to be really fast. So if I was you, I would play around with this setting to see what gives you the best user experience for your application and then stick with that. I wouldn't just choose one and then leave it. Okay, so the next thing we need to do is to execute this with tRPC with my app. So let's get started building out our app router. Inside of source, I'm going to create a new folder and I'm going to call this server. And then in server, I'm going to create another folder and I'm going to call this route. And then I'm going to create a file inside of server. And this is going to be called create router.ts. And then inside of route, I'm going to create a couple of files. The first one is going to be app.router.ts. The next file is going to be user.router.ts. And then finally, we're going to have post.router.ts. You don't have to split your routes into these different files. You could just stuff everything into app router if you wanted to. I wouldn't recommend it if you're going to be building an application with any considerable size because it's going to get quite hard to manage. Inside of create router, I'm going to import from @trpc/server, and I'm going to import router. You don't have to do this if you don't want to. This is just a nice little helper function that means we can call create router and it's going to be fully typed for us every time. So I'm going to export function create router and we're going to return router and we can pass in a generic here. So I'm just going to add another to do. Add context to generic. We're going to execute router and then we're going to call .transformer and we're going to pass in super JSON again. And this means that we also don't need to call .transformer on every single router that we create. And we're going to be creating 3 routers, app, post, and user. I'm going to import from super JSON. Okay, so inside of server, I'm going to create another file and I'm going to call this create context.ts. And then I'm going to define a function called create context. And I'm just going to export create context as a named export. Create context is going to take one argument, and that's an object. And then inside of the object, we're going to have our request, and we're going to have a response. And these are going to be typed as request, next API request, and then response is, you guessed it, next API response. So for now, I'm just going to return an object. And this object is going to be request and response. And I also want to create a type here. So I'm going to say export type context is equal to return type. And I just want the return type of whatever context is going to return. So I'm going to say type of create context. And this is type of, not type. So you can see here our context is of type request and response, which is next API request and next API response. Okay, so now we have our create context function that we're going to build out a little bit more later on to add our user. And we have our context type. So let's come back to create router. And now on our router here, we can say that the generic is going to be of type context and make sure this comes from create context. Okay, and we can remove this to do. Okay, so now we have our create router utility. We can come over to app routes. And I'm going to export const app router is equal to create router. And create router is just going to come from our create router function that we just generated. We need to execute create router. And then we can add a query And I want to call this query hello. And then the next parameter is going to be an object. And an object is going to have several different properties. The most important one is this resolve. And this is going to tell tRPC how to resolve this hello query. So this is going to be a function. And I'm just going to return some text here. And this text is just going to say hello from tRPC server. So now that we have our app router defined, we can define a type from this. So I'm going to export type app router is equal to type of app router. And then we're going to have everything that we need on this one type. Let's go back to _app and we can now type this out here. So with tRPC takes a generic and we can pass in app router and we can remove this to do. And there was one other to do we had inside of utils. So we have a to do add app router as a generic. So inside of here, we're going to add a generic of app router and we can remove this to do here. So when we import tRPC into our client, we're going to have all of our types from app router. So we're going to know what queries and mutations we have. And we also know what those queries and mutations take as arguments and what they're going to return. And what they're going to return is inferred from the actual resolver returns. So you can see here that hello is just going to return a string. Let's test this out. If we come back to our pages and our index page, I'm just going to remove everything here. Then I'm going to say const object is equal to tRPC and make sure this comes from util / tRPC. And then we're going to call dot use query, and use query is going to take an array and the array is going to be hello. So if hello had some arguments, we would need to put it in as the second property inside of this single array here. Then use query is going to return data, an error, and it's also going to return a loading state. And this is going to be inside of is loading. So we can say if is loading, then we want to return a p tag that just says loading. Otherwise, let's just json.stringify data. And then also if we have an error, so if error, let's just return a div and we'll json.stringify the error as well. Let's start up our application with yarn dev. And we can go over and have a look at what this looks like in the client. And inside of the client here, we have a 404 error. So we're making a request to /API/tRPC/hello. So if we go into /API, we have nothing. So this means that we need to set up our tRPC handler inside of our API folder. So inside of API, I'm going to create a folder called tRPC. And then inside of there, I'm going to create a new file with square brackets, tRPC.ts. So inside of this tRPC file, I'm going to export default. And this is basically just a Next.js route handler. And tRPC is going to intercept the request and response and do its magic with it. So we're going to return tRPC next. And we need to import this. So let's import star as tRPC next from @tRPC/server/adapters/next. There is different adapters you can use. If we go into here, you can see there's a next adapter, which we're going to be using, a Lambda adapter, Fastify, Express, AWS Lambda, and standalone and Node HTTP. There's also a WebSocket adapter. So if you like how tRPC works, but you don't like Next.js for some reason, then you don't have to use Next.js. You can use one of these other adapters. Then we can call tRPC next.create next API handler. We're going to execute that with an object of properties. Then we're going to have our router, and this is going to be our app router. Then we're going to have create context, and this is going to be the create context function that we created earlier. So create context, I'm just going to try and name that create context, and this is going to come from server/create context. I'm just going to remove this double name here. And then we're going to have on error, and this is just a custom error handler. So we're going to get our error in here. And then what we define here is going to be sent to the client. So I'm going to say if error code is equal to internal server error. And you can see that we're already getting some TypeScript helpers here. I want to console.log something went wrong. And I'm also going to append the error here. I probably should console.error here instead of console.log. Else, I'm just going to console.error, and I'm just going to log out the error. So if we go over to our client, we're getting an error here, and we're getting a 404 error. If we come back and look at our application, everything looks correct. The problem we have is API isn't inside of pages. So we need to drag API down inside of pages. We need to update the imports. Then if we go back over to our application, you can see that we get a string here, hello from the tRPC server, and we have a network request to /API/tRPC/hello. We can open this up inside of a new tab, and you can see that we get this response here. We get a result of type of data, and then the data is going to be JSON, and we get our string here. So now that we've completed setting up tRPC, let's go register a user. So the first thing I'm going to do is to initialize Prisma. So inside of my notes file again, I'm going to grab this npx prisma init command. This is going to initialize Prisma for us. And so we get a few different things. We're going to get this .env, and this is going to be a string to connect to our database. I'm going to change mine here to Postgres, and then my password is change me. And then I'm going to call my database here, tRPC tut. The next folder we're going to get is Prisma, and then inside of Prisma, we get this schema.prisma, and this is where we're going to define all of our models. So defining models in Prisma, if you're not familiar with it, can be a little bit overwhelming at the start, but once you've done it a couple of times, it actually gets really easy and it's really enjoyable to use. So I'm going to say model user, and I'm going to define a few properties on this user. The first one is going to be an ID. This is going to be a string. I'm going to have an @unique constraint, and this means that ID has to be unique, and we're also going to get an index on ID. Then I'm going to have @default, and this is going to default to a UUID. Next, I'm going to have email. Email is going to be a string, and it needs to be unique as well. And this means that we're going to get an index on email too. So we're going to be able to look a user up by an ID or by an email, and it means we're looking them up by an indexed field. Next property is going to be name, and this is going to be string. I'm going to have created at. This is going to be a date, and the default is going to be now. It's actually going to be date time. I'm going to copy this down, and I'm also going to have updated at, and then the default is going to be this handy little function called updated at. So these are all the fields we're going to have for our user for now. The next command that I want to run is going to be our npx prisma migrate. So I'm going to copy that, and I want to give this a name of user. So now that this has run successfully, it's done a couple of things. The first one is to create this migration file with this Unix timestamp. And then the second one is that it actually ran the migration and created the user table for us. So if we have a look in the migration, you can see what it's done for us. It's created a table called user with the fields that we defined. It's created a unique index for ID and another index for email. Let's come back over to our routers. And inside of user router, I'm going to say const user router is equal to create router. Then I'm going to have .mutation, and I'm going to call my mutation register user. Then I'm going to have a function here. I'm going to have resolve, and resolve, it's going to be a function, and resolve is going to be an async function. There's two different syntax styles you can use here. You can have resolve as a property that just returns a function, or you can have resolve as an async function. So we can say here that this is async, and both these are valid syntaxes. The reason that both of these are valid is because this is just plain JavaScript at the end of the day, and that's what JavaScript will accept on objects. So before we build out our user router, there's a few things we need to do. First, we need to export it. The second thing is come over to app router. I'm just going to remove this query. We don't want this anymore. Then I'm going to call .merge, and I want to merge on my user router. So I'm going to have users dot, then I'm going to have user router. So the reason I use users dot here is because I want my queries for user to be something like users dot, and then the mutation is going to be register user. Then we're going to have a query for me, and then all these queries are going to be prefixed with users dot. You don't have to do this if you want. You can also make this a singular user, but I like it to be users because it follows a REST style naming convention. So the next thing we need to do is come over to utils and create a new file called prisma.ts, and this is going to be our Prisma client. And in this file, I'm going to import Prisma client from @prisma/client. Then I'm going to say const prisma is equal to new Prisma client. And we need to export this as well. The issue with this is you may get a warning in your console that says there are already 10 instances of Prisma client running. The way to fix this is to add Prisma client to a global. So we need to declare global, and then we can say var Prisma, and this is going to be of type Prisma client or undefined. And then we need to say Prisma is equal to global.prisma or new Prisma client. So if global.prisma exists, we're just going to use whatever is already on global, and we're not going to create a new Prisma client every time. And then we need to say if process.env.nodeEnv is equal to production, so it's not equal to production, then global.prisma is equal to Prisma. And this is going to stop Prisma from creating new instances every time this file is called. Then I'm going to come over to create context, and inside of create context, I'm going to import from utils/Prisma, and I'm going to import Prisma. Then I'm going to add Prisma to context. Now, if we come back to user router, we can get context in the resolver. Now, if we say context.prisma, Prisma is now available on context. So the other thing I want to do is set up our create user schema. So inside of our source directory, I'm going to create a new folder here, and I'm going to call this schema. Inside of schema, I'm going to create a file called user.schema.ts. I'm going to import Z from Zod. If you haven't used Zod before, you're in for a real treat. It's actually a really nice validation library, and it's going to work really well with TypeScript, and that's why it was chosen for tRPC. So I'm going to export const create user schema is equal to z.object. We're going to execute this with an object. Then we're going to say name z.string. Then we're going to have email z.string.email. And you can see how easy this is already. We're going to get email validation on this field by just calling .email. Next, I want to export a type from here. So I'm going to export type create user input is equal to z.typeof. And this is your generic that takes type of create user schema. Now, if we hover over this, we have a type called create user input, and this is going to have two fields, a name and a string, and both of them are required. If you want one to be optional, you can just call .optional, execute that. And now if we hover over the interface again, email is now optional. So it could be an optional parameter of string or undefined. We want both of these properties to exist. Let's go back to our user router, and just above resolve, we have a few other properties we can use. So we can have input, and this is going to be our create user schema. And then this is going to validate our input for us. And tRPC is going to infer the types from there. And then when we call the mutation on the client, we're also going to get type validation there. You have another property here called output, and you can provide a schema here. So we could come into user schema, and we could say export const create user output schema is equal to z.object. Then we can copy these properties here, and then this is going to validate our output. So create user output schema. And now we have validated input and output. You can see that we have an error here. No overload matches this call. And the reason we're getting this validation is because we added our create user output schema. If we copy that out, TypeScript is no longer complaining. So this is another level of validation you can get on the server. One of tRPC's mottos is move fast, break nothing. And this kind of stuff really proves that they're aiming for that, and they're doing a great job of it as well. But we don't actually want to return the user from this function. So let's just remove this schema here. And I want to say const user is equal to await context.prisma.user.create. I want to pass in a data object, and data is going to have our email and name. Let's extract these out of input. So on resolve, we get another property here called input. So I'm going to say const is equal to input. And you can see here that these are going to be typed. So we're going to get email and we're going to get name. If we try to get another property here called Bob, you can see that Bob doesn't actually exist on our input type here of name and email. And that is inferred from our Zod schema. I'm going to add email and name. Then I'm just going to return our user here. So there's one issue. We have unique constraints on email and ID. The user can't pass in an ID, but they can pass in an email. So they might try to register a user that is already registered. And if that's the case, we want to catch that error and we want to return an appropriate error. So I'm going to wrap this in a try catch block. Now I want to say if error is an instance of Prisma client known request error, and if error.code, and you can see that error is typed here now. So if we say like if error.code above here, error is not typed because we've tested it to see that it is type of Prisma client known request error, we get typing on this error here. Is equal to P2002, and this just means that we've violated a unique constraint. Then we want to throw a new tRPC error. So throw new tRPC, and the tRPC we want is going to come from tRPC server. So let's just go up and import that manually so we know we have the right one. Import star as tRPC from at tRPC/server. So throw new tRPC.tRPC error. Then our code here is going to be conflict. And you can see that we get some really nice validation here. So we don't need to remember the HTTP status code for each error. We can just say a conflict. And then the message is going to be user already exists. If our error is not an instance of Prisma client known error, then we just want to throw a new tRPC.tRPC error. We want our code to be internal server error. Then our message is just going to be something more obscure, such as something went wrong. You can test for other error types in here if you like, and that's going to make your API a little bit more robust. Now that we have our register user handler, we can go build a user interface for this. So inside of pages, I'm going to create a new file, and I'm going to call this register.tsx. And inside of this register component, I'm going to say function register page. Then I'm going to export default register page. And I want to return, and I'm just going to return a fragment because I'm going to have a form. And then down below the form, I'm going to have a link. And this link is just going to be to the login page. So if the user does have an account, then they can log in. And I'm just going to say href =login. So as the form handler, I'm going to use React hook form. So I'm going to say const equals use form, and use form is going to come from React hook form. And in here, I'm going to get handle submit, and I'm going to get register. Then I'm going to get my mutation and my potential error that the mutation could return. So I'm going to say const equals tRPC dot use mutation. And use mutation is going to take an array, just like use query. And you can see here that we're getting some autocomplete. So we have users.register user. Use mutation is going to return mutate, and it's going to return error. Under the hood, tRPC is going to use React query. And so React query is going to return this mutate function here, or it's going to return mutate async. If we go over to the React query docs, and we have a look at what mutate async is going to do, we can use this instead of mutate to get a promise which will resolve on success or throw on error. So what this is going to mean is we're going to have to handle our errors ourselves. Whereas if we just use mutate, we can call this on success inside of our mutation. So in most cases, you're going to want to just use mutate and not use mutate async. Because if we come into our use mutation, we get this object here and we can call on error. And then we get this function here, and inside of this function, we're going to have our error. And then we're going to be able to use this error. We're also going to get on success, and we can do things in on success, such as redirects and displaying messages. So inside of our form, I just want to say if we have errors and error.message, then we're just going to display the error message. When the form is submitted, we want to handle that with an onSubmit. And then onSubmit is going to call handle submit. And then we can pass in a function here. I'm going to define a function called onSubmit. And then I'm going to pass onSubmit into handle submit. And then onSubmit is going to get the values. So I'm going to say values. And then I want to call mutate with our values. So inside of our user schema, we exported this create user input. So we can use this to type the input for our form. So I can say use form is create user input. And then values here is also going to be create user input. And now we have no TypeScript errors. So inside of our form, I want to define a H1, and this is just going to say register. Then I want to have input. This is going to be type of email. It's going to have a placeholder of email. Actually, let's make the placeholder jane.doe@example.com. Then we want to register this field with React hook form. I'm going to open up these brackets, and then I'm going to spread register. And then I want to provide the name of the field. So this field is going to be email, and you can see we get some type safety here. And that's because we typed our form up the top. Okay, so let's add a break tag. Copy this field down below. This type is going to be text. The placeholder is just going to be Tom. And then I want to register a field with the name of name. Down below, I want to have a button. This is going to be register. And then the type is just going to be submit. So when the user successfully registers, I just want to redirect them back to the login page. So I'm going to get router. So I'm going to say const router equals use router. Then I'm going to say router.push /login. Remove this error handler here because we're going to handle our errors with this error object here. Our register page here has a capital R, but it actually needs to be a lowercase r. Let's copy our register page, and I'm going to call this login. And then I'm going to remove the name portion of the field. I'm going to have a href to register. And then the link text is just going to be register. Then the title of the field is going to be login. And then we're just going to comment this out for a second because we don't actually have a handler for logging in a user. just going to comment that out, and then I'm going to comment all this out as well. The reason I'm just making this page now is because we're going to link to here after we register a user, and I just don't want it to return an error. Let's go back to our page, and I'm going to go to /register. We get this form here. So I'm going to register with t@t.com, and then the name is just going to be Tom. Let's click register. We get redirected back to login. So it looks like this was a success. You can see that we called /API tRPC users.register user. A big advantage of tRPC over something like GraphQL is there's a lot of similarities, but you'll notice here that this is a post request and it returned a 200. Let's try register this user again and see what it returns. So I'm going to register t@t.com, and I'm going to call this user Tom again. Log in, and you can see that this has actually returned a 409 conflict, whereas something like GraphQL would have returned a 200, and then the errors would have been in the response body. I'd much prefer having these proper HTTP status codes. It's much more reflective of what is actually happening, and it follows the REST API standard. The other thing you'll notice is that queries are GET requests and mutations are POST requests. So this helps you differentiate the two when you're looking through your network requests. Okay, so we've registered a user. Let's go start building out a handler for logging in. So I'm going to come over to the Prisma schema here. And to log in, what we're going to do is we're going to get the user to provide just an email address, no password. Then when they provide a valid email address, we're going to create a login token for them. Then we're going to send them an email, and then the email is going to link back to our website, and we're going to provide the login token and the email to the server. And if the login token matches something that we have stored in the database for that user, then we're going to sign a JWT for them, and they're going to get a cookie, and they're going to be successfully logged in. So let's provide a model for our login token. So I'm going to say model login token. We're going to have an ID. This is going to be a string. It's going to be unique. And the default value is going to be a UUID. I'm going to copy created at because we want to know when this token was created. So if you wanted to, you could revoke it after a period of time. And then we want to assign this token to one specific user. We don't just want any user to be able to use any token. So I'm going to say user is equal to a user. We're going to have an @ relation. And then the fields that we're going to relate to is user ID. And we need to create user ID down here. So I'm going to say user ID is a string. Then this is going to reference the user's ID. So Prisma is giving us an error here, and it says that field user in model login token, the relation field user on model login token is missing on the opposite relation. So what it's telling us is that we need to add login token to user. So we can do that manually if we like, but we can also run npx Prisma format. So I'm going to say npx Prisma format. And you can see that Prisma has now added a login token to the user model. The last field that I want to add to our login token is a redirect. So let's say we show the login form on a page that's deep inside the application. Say we have a post and we want users to be logged in to be able to comment. We can put the login form down where the comment section would go. But when they log in, they're going to request a login token. And then from their email, they're going to click back to our website. And we want them to go back to that post where they originally were so they can leave their comment. So I'm going to add a redirect. This is going to be a string, and then we're going to default to just a /. And this means that if we don't have a redirect field, then we can just default it back to the index of our site. Okay, let's run npx Prisma migrate, and then I'm going to call this migration login token. So we've created our migration and we've run it. So we've created the login token table in our database. Now we can come over to the user router, and I want to create a mutation here. And I just want to call this mutation login. I actually think we can do better than login here because login doesn't tell us what strategy we're using to log in. We could have this OTP login strategy, but we could also have a couple of OAuth strategies and a SAML strategy, and we'd need to create different mutations for those. So let's be more specific in what this actual function is going to do. So let's say request OTP. So this just means request a one-time password, and a one-time password is our login token. We're going to have our object here. Let's open this up, and I'm going to collapse the resolver. So you can see here we need an input schema. So let's come back over to user schema, and I'm going to say export const request OTP schema is equal to z.object. Then we're going to have an email, and this is going to be z.string .email, and that's all we're going to have. We're also going to have a type for login. So I'm going to say export type request OTP input is equal to z.typeof request OTP schema. So now we can use this schema. So inside of our mutation here, I'm going to have input of request OTP schema. Then I'm going to have async resolve. So the first thing we want to do is destructure our email and our redirect out of input. Actually, on register schema, we need to have redirect as well. So I'm going to say redirect z.string, and then I'm going to default this to just a slash. So on the client, we're going to be able to pass in a path that the user is on when they request a one-time password. So I'm going to say const equals input, and we need to get input out of resolve. So I'm going to say input. We also need context. Input. We're going to get our email, and we're going to get our redirect. Next, I want to try find the user. So I'm going to say const user equals await context.prisma.user.find unique. And I want to find the user by the email. So I'm going to say where email. So if our user doesn't have an account, we just want to return a 404. So I'm going to say if not user, throw new tRPC .trpc error. The code is going to be not found. Then the message is just going to be user not found. So if we do have a user, we want to create a login token for them. So I'm going to say const token equals await context.prisma.login token.create. I'm going to provide some data. So I'm going to provide the redirect, and I want to connect the user to the login token. So I'm going to say user is equal to connect, and I want to connect the user where the ID is equal to the user ID. When we've created our token, we want to be able to send email to user, and then we just want to return true. Okay, so we can't send an email yet, so let's go create our mailer. So inside of utils, I'm going to say mailer.ts. So there's lots of different ways to send an email. You could use something like SendGrid, but we're going to be using node mailer. So I'm going to import node mailer from node mailer. And in fact, you can use node mailer with something like SendGrid because they're going to give you some SMTP credentials that you can use inside of your application. Then I want to export async function send login email. So inside of our send login email function, we need to get a test account. So I'm going to say const test account is equal to await node mailer dot create test account. Then I need to create a transporter. So I'm going to say const transporter is equal to node mailer dot create transport. Then our host is going to be smtp dot eternal dot email. And this is what we're going to use to preview the email. Then our port is going to be 587. Then secure, we're going to set this to false. And then for auth, we're going to use our test account. So I'm going to say user is equal to test account dot user, then pass is equal to test account dot pass. Next, we're going to say await transporter dot send mail. I want to say from, then I want to put in a name here. I'm going to put Jane Doe. And then the email is just going to be j.doe@example.com. You obviously want to put your email address and your site name and everything in here that you're going to be sending the emails from. So our to is going to be email and we need to get email in our argument. So I'm going to say email. Email is going to be a string. Then our subject is just going to be log in to your account. And then our HTML is going to be log in by clicking here. And then this is going to be HTML. So I can provide an anchor tag with a href. And then the href is going to be our URL, which we need to pass in as an argument. And this is going to be a string. /login. And then we want to provide a token. So there's two ways we could do this. The first way is we could add a query string. So we could say token equals, and then we have our token here. But the second way is we could add a hash. And this just denotes a section on the page. And then we could say token equals, and we can add our token. I'm going to use the hash. And the reason I'm going to do that is because if we use the query string is going to get saved in the browser's history. And therefore we're saving tokens, even though they're being used in the browser's history. But we don't want that to happen. So I'm going to add the hash, and then this token is never going to get saved in the browser's history. We need to add our token to the input. And our mailer is ready to go. Send email is going to return an object. So I'm going to say const info is equal to, and now I just want to log out the address that I can access this email. So I'm going to say console.log preview URL. And then I can say node mailer dot get test message URL, and then we just need to pass in info. Okay, so now we can use this mailer. I'm going to say await send login email, and we need to pass in our token. And I'm just going to pass this in as an empty string for now. And we need to pass in our URL. We defined our URL earlier inside of _app. We have a look here, we defined it. Let's copy that out. So I'm going to cut that. Inside of source, I'm going to create a file called constants.ts. I'm going to paste in email. I'm going to export that. I'm going to come over to app, and I want to use the URL from constants. So I'm going to import from constants the URL. And then I can pass in our URL from constants. And I also need to pass in the email, and the email is going to be user.email. So for our token, I need to pass along the email address, and I need to pass along the ID. I'm going to do this by base64 encoding the two. So inside of utils, I'm going to create a new file, and I'm going to call this file base64.ts. The reason I'm going to base64 encode this is because I want to pass along the user's email, and I don't want to really pass that around in plain text. Base64 is not encrypting or hashing, it's just going to obfuscate the email address. So I want to export two functions from here, one to encode and one to decode. So I'm going to say export function encode. We're we're going to get our data. This is going to be a string. And I want to return buffer.from data. I want to encode this with UTF-8. Then I want to call .toString. And inside of .toString, I want to base64 encode. So decoding is going to be relatively similar, just the other way around. So I'm going to say export function decode data is going to be a string. Then I want to return buffer.from data, and this is going to be base64 as the input to string, and I want the output to be UTF-8. Let's use our encode function here. I'm going to say encode. Now I want to encode a string that is a concatenation of our token and our email. So I'm going to add the token.id. Then I'm going to add a full colon, and then I'm going to add user.email. So let's go back to our login form, and we should be able to use this now. So I'm going to uncomment this, and I'm going to have users.request OTP. And after we successfully log in, I'm going to have a state parameter, because use state. This is going to be false. I'm going to call this success, set success. Then I just want to set success on success to true. And then once they've logged in, I can just say, check your email address. Now I can call mutate. And if we've successfully registered a token, I want to uncomment this error as well. I want to say success, and then we can add a p tag. And then this is going to say, check your email. So the last thing I need to do is add a button, and this is going to say login. Now we can go test this out. We have t@t.com, login, cannot read property of undefined, reading create. So I'm going to go back and I'm going to have a look at the errors here. And I'm assuming this is going to be in the user router. So I think the issue here is that I need to stop the server and restart it again. Let's try this. So I have a get address info error not found, smtp.ethernal.email. So I think in my mailer, I have an error with my SMTP server, and this is supposed to be ETHEREAL, ethereal or something. Come back and we try login again. And now this says check your email address. The reason that took so long is because we're awaiting for SendMailer to send the email address. If you don't want to await that and you want to respond to the user quicker, we can remove the await. But if you want to catch any errors from your email provider, this is not going to allow you to do that. Now we can log in again, and you can see that this request responds in 145 milliseconds instead of 4.5 seconds. So let's click this link here, and it says log in by clicking here, but we have no link. So let's go check our email template. Then I'll come over to mailer, and we haven't actually closed our anchor tag here. So I'm just going to say here, and then I'm going to close the anchor tag. I'm going to remove this here. Then let's go try this again. Log in, wait for our message in the console. And we can click that. Now we get some text. We can click it, and we go to /API/tRPC/login. And that's because our URL that we're passing in has tRPC in it. So I'm just going to say export const base URL is equal to, then I'm going to copy this URL. Then I'm going to remove the /API/tRPC part. Next, I can use base URL inside of URL. I can say base URL/tRPC, or this is going to be our base URL of localhost. And these two are the same here. So we can actually say that URL just equals a base URL /API/tRPC. And now we should be good to try this again. Click login, wait for our link, and we get the same error. We need to actually use base URL inside of our email template. So come back to user router, and URL is going to be base URL. Now let's try this again, third time lucky. Click login. Okay, so now we come back and we have this login token in the URL. Let's decode this token. So now what we need to do is we need to check the URL to see if this token exists. And if it does, then we need to make another request to verify the token. So inside of our login page, let's create a component at the top here called verify token. So function verify token. And for now, I just want to return a p tag that says verifying. And next we want to get the hash out of the URL. And if we have a hash, then we want to return this verify token component instead. I'm going to say const hash is equal to router dot as path dot split. And as path is going to be this section here /login and then the hash of our token. So we want to split this by hash token equals, and then we want to get the first argument, and then we want to say if hash, then we can return verify login, and we need to render this. So now let's go back, and you can see that our page now says verifying. So we have the hash in the URL. Let's go to this other login page where we don't have the hash in the URL, and we can refresh this, and we can see that we still get the login screen. Okay, so we need to make a handler for verifying the token. Let's go back to user router. Now I want to make a query here. So I'm going to say dot query. And this is going to be verify OTP. So verify one-time password. We need a schema for this. So let's come back to user.schema. I'm going to export const verify OTP schema equals z.object. Now we're going to have one property in here, and this is going to be our hash. So I'm going to say hash z.string. Now we can say that our input is verify OTP schema, and then we have async resolve. And in resolve, we're going to get our input, and we're also going to get our context. Now we want to decode our token. So I'm going to say const decoded equals decode input.hash.split. And then remember, we encoded this with a colon. So we want to split by that colon. And decode needs to come from util/base64. Now we have an array with two properties, and we can destructure those out. So I'm going to say const equals decode. And we have our email and we have our ID. But our ID is actually first, which is important because this is an array. And this is going to come from decoded. Next, we want to find our login token. So I'm going to say const token equals await context.prisma.login token dot find first. And I want to find where ID is equal to ID. And I want to find where the user is equal to email. Once we get the token, we want to sign a JWT. So we could make a query to get the user, but we're already getting this token, and users are joined to tokens. So down under below where we can say include, and we can include the user and set this to true. And now our token is going to include the user object. If we don't have a token, we want to throw an error. So I'm going to say if not token. This means that we haven't been able to find a token by the ID and the email address. We're going to throw new tRPC dot tRPC error. And the code is going to be forbidden. And then the message is just going to be invalid token. If we do have a token, we want to sign a JWT. So to do that, we need to create some utilities for signing and verifying JWTs. So inside of the utility folder, I'm going to create a new file called jwt.ts. I'm going to import JWT from JSON Web Token. I'm going to say const secret is equal to process.env.secret or change me. So we're going to use this secret to sign and verify a JWT. There's two different ways that you can sign and verify JWTs. One is with a string or a secret like this, and the other is with public and private keys. So with public and private keys, you would sign the JWT with a private key, and then you would verify that it's been signed with its matching public key in the verify function. The public and private keys are a much more secure way to sign and verify your tokens. However, in this tutorial, I'm just going to use a secret because it's a little bit easier. So I'm going to export function sign JWT. We're going to take some data, and this is just going to be an object. Then we're going to return JWT.sign. We're going to sign our data, and we're going to sign this with our secret. Then to verify JWT, I'm going to export function verify JWT. We're going to take a token, and this is a string. Then we're going to return JWT.verify. We're going to pass in our token. We're going to verify with our secret. And we want verified JWT to return our context user. So I'm going to pass in a generic here, and then I'm going to say JWT.verify as T. And this means we can pass in what we want our verified JWT to return. So come back to user router, and I'm going to say const JWT equals sign JWT. Then I'm going to pass in my token.user. And if you have anything sensitive stored on the user, you'll want to omit that. So you could do something like email is going to be user token.user.email. And then we can do the same for ID. Is going to be token.user.id. And next we want to set a header of set cookie to tell the browser to set a cookie with our JWT as the value. So I'm going to say context.res, and res is available on context because in create context, we added our response here. .set header. Now I want to call this header set cookie, and we want to serialize a cookie. So I'm going to say serialize, and serialize comes from this cookie package. I'm going to call it token, and you can call this cookie whatever you like. I'm going to make JWT the value, and then I'm going to set the path to just \. And next I want to return an object. I want to return with a property called redirect. And this is going to be token.redirect. And this is going to tell the client where it should redirect to. So let's come back to login, and we're going to fill out our verify component here. So I want to use a query, const equals tRPC.useQuery. Query is take an array, and this query is going to be users.verify.jwt. We only have one query here, and that's because in our router, we only have a single query. This also takes some arguments. So you can see here that TypeScript is telling us that we're missing hash, which needs to be a string. So I'm going to say hash, and we need to pass hash into verify token. So I'm going to say hash, and then hash is going to be a string. So down where we're calling verify token, I'm going to say hash is equal to hash. So we're going to get data and is loading. So I want to say if is loading, then we just want to return verifying. Otherwise, we want to return redirecting. And then I want to get my router. So I'm going to say const router is equal to use router. Then I want to push to the redirect URL. So I'm going to say router.push data.redirect, or it's just going to be \. So router.redirect, if they go from the login page, is going to be set to login, but we don't want to redirect back to the login page. We just want to redirect back to index. So I'm just going to say router.redirect includes login. Then we're going to redirect back to the index. Otherwise, we're going to redirect back to data.redirect. So let's go over and try this out. I'm actually going to remove the redirect here so we don't get redirected away. let's try log in again. So I'm going to say t@t.com, log in. I'm going to go to the email, click on the link. So if we come over to our client, you can see that we get this error here. Hydration failed because the initial UI does not match what was rendered on the server. The reason it's doing this is because exactly what it's telling you, what's rendered on the client and what's rendered on the server are two different things. The reason for this is because if we log out what router is on the server, so console.log router, and then we refresh our page, so you can see that on the client, our router has our as path with the hash, and this all looks good. But if you have a look at router on the client, our as path just has login. So there's two ways to fix this. One, you could just use query strings and that will be available inside of router, or you can move login to a different component and we can use Next dynamic to import the component. So I'm going to copy everything in the next page here. So I'm going to create a new folder called components. And then I'm going to create a new component called login form.tsx. I'm just going to rename our login page here to login form. Then on our login page, I'm going to render out our login form. So this is called register. I'm going to call this login page. I'm going to remove everything here. And I'm going to return just a div with login form. Now we're importing login form here, but we can import dynamic from Next dynamic. Then we say const login form is equal to dynamic import, and then we can import this from components / login form. And now we can give this some options here. I'm going to say SSR false. Now if we clear this out and refresh, you can see that we no longer get the error and router no longer console logs on the server. So we can also remove verify token. And that's because login form is no longer being rendered on the server. Let's go back into login form. And you can see that we're doing the query here to get and you can see that we're doing the user.verify OTP query. So we should expect a token to be set. And inside of our cookies, we do see that token. So now we can use this token to get the currently logged in user, and we can do that when we create context. So I'm going to come back to create context. So before we get the currently logged in user, let's just add some finishing touches here. So I'm going to uncomment this router.push. So we're going to do the redirect. When we log in, we're not actually passing along the current route, so we can do the redirect. So in our onSubmit handler for login, I'm just going to spread out our values. Redirect is our router.asPath. So now we can render this login form on any page, and we're going to get redirected back to that page when we log in. On our index page here, we're using this query for hello, which no longer exists, so we're getting some errors. So I'm just going to remove all of this, and then I'm going to print out index. So let's go over to create context, and I'm going to define an interface for our context user. So I'm going to say interface CTX user. We're going to have an ID, which is a string. We're going to have a email, which is a string. We're going to have a name, which is a string. We're going to have an IAT, which is going to be a string. Then we're going to have an expiry, which is EXP, which is going to be a number. Above create context, I'm going to create a new function called get user from cookie. Actually, this is going to be get user from request, because we're just going to pass in the request, which is going to be of type next API request. Then we're going to say const token is equal to rec.cookies.token. Then we're going to say if token, but if we don't have a token, we're just going to return null. So this function here is going to either return a context user or it's going to return null. I'm going to say try, and then I'm going to catch, because our verify function can throw an error. And if it does, we don't want to throw an error. We just want to return null. and say const verified is equal to verify JWT. I'm going to pass in the token. And if we have a verified user, I'm going to return verified, and this is going to be our user. If we hover over what we're going to return here, we're going to return unknown. If we go back to our verified JWT, we passed in a generic here. So we can pass in a generic of context user. And now our function is going to return context user or null. So now when we build context, we can say const user is equal to get user from request, pass in our request, and then we can just add user to context. Now, if we come back to our user routes, we can have another query here for me. Then the resolver is just going to return context. Then we're going to say context.user. Now we can go back to our index page and we can add a query here for context user. So this is going to be tRPC.useQuery users.me. And we have all of our data and everything from before. Let's go back to our index and you can see that we have our user here now. Okay, so let's create some context so we can store in our user and we can just use that throughout our application. So inside of source, I'm going to create a new folder and I'm going to call this context. Inside of context, I'm going to create a new file called user.context.ts. I'm going to have a constant called user context is going to be equal to create context, which comes from React. We're going to default the value to null. I'm going to have a function user context provider. This function is going to take two arguments. One is going to be children, and then the next argument is going to be value. We can type this out. Children is going to be equal to React.React node. And value. So our value here is going to be me, and we know we have context user, but we can also infer the value here from our tRPC client. So to do this, first I'm going to say type t query is equal to key of app router. Then I'm going to get def and queries. Then I'm going to say type infer query input. Then we're going to have t route key extends t query, and t route query has a capital T, is equal to infer procedure output, which comes from TRP server. And then in here, we're going to have our app router. Then we're going to get def. We're going to get queries. And then we're going to get t route key. And t route key, if you have a look, if we try to put a string in here, it's trying to get our query. So we have users.me and verify OTP. But this is going to be a generic type, so we could use this anywhere technically. Usually you would have a types file and you just export these and then you use them throughout your application. So I have one little mistake here. This is infer query output. And now we can move use context down, and we can use this in the generic that create context allows us to pass in that is defaulted to null. So I can say infer query output. And then the query that I want to infer the output of is users.me. So now if we have a look at this, you can see that use context is react.context with context user or null. And we can also use our infer query output here to infer the type of users.me query or undefined. So now let's return user context dot provider. We're going to pass in our children. Then we can close this off. We have an error here. It says cannot find namespace user context. And this seems really weird because user context is just here. The reason is we're now using JSX in a .ts file, and that's not going to be liked by TypeScript. So we need to change that to TSX. And now we get a different error that we need to pass in our value. So that's fair enough. So we can say value is equal to value, and we still get errors here. And it says type context user null or undefined is not assignable to context user or null. And that's because our user context here is context user or null. So we could just say value or null. So let's export a hook here. So I'm going to say const use user context is equal to a function that returns use context, user context. Then we're going to export use user context and our user context provider. Now we can use this in our underscore app, and how you use this is going to depend on what your application's requirements are. So I'm going to copy my user query here, and I'm going to use this inside of my app. I'm going to make sure tRPC is imported from utils. Then I'm going to say if is loading return loading user. Otherwise, going to wrap our component inside of user context provider. And we're going to pass in a value here, and the value is going to be data, and our data is going to be our context user, null or undefined. Okay, I'm also going to wrap this in a main component here, and that's just because I have some styles attached to main, and they are going to make the application easier to see. Okay, let's go back to index. And I can remove this user query here, and I can say const user is equal to use user context. Next, I can say if not user return, and I just want to return our login form. Otherwise, I want to return div here, and I'm going to have a link. And my link is going to be to create a post. So I'm going to say create post. href is going to be /posts/new. Remove this last return here. So now we have this create post link, but we don't have a page to create posts on. So let's come back to our routers, and inside of our post router, let's start creating our post queries and mutations. So I'm going to export const post router is equal to create router. And before we forget, I'm going to add our post router to our app router. So I'm going to merge posts dot, and then I'm going to add my post router. And the reason I'm going to do this now is because if you don't do it now, you're going to wonder why your post queries and mutations don't show up on the UI. And that would be because you've forgotten to add this merge statement here. So I'm going to add a mutation for creating a post. Then I'm going to have two queries, one for posts, and then another query for single post. And this is just getting a post by the ID. Okay, let's create a schema for our post. So inside of schema, I'm going to create a new schema called post.schema.ts. I'm going to import Z from Zod, export const create post schema is equal to z.object. The title is going to be a z.string. And then the body is going to be z.string. You're going to also add some constraints here. So I can say .min, and we don't want posts with a minimum length of, say, 10 characters. And then for title, I could add a max, for example, and I don't want a title with a max of say 256 characters. And then we can add an error message here that says max title length is 256. 256 needs to be a number, not a string. Then I want to export a type. So I'm going to export type create post input is equal to z.typeof create post input. So it's type of create post schema. Then I want to have another schema here to get a single post by the ID. So I'm going to export const get single post schema is equal to z.object. Then I'm going to have the post ID, and this is going to be z.string. And then I'm going to have .uuid because I know my post IDs are UUIDs. Okay, before we go any further, we need to make sure we add our post to our Prisma schema. So I'm going to say model post. I'm going to have an ID, and I'm just going to copy this from our login token because it's going to be exactly the same. We're going to have a title, which is going to be a string. Then we're going to have a body, which is going to be a string. We're going to have a created at and updated at. I'm going to copy that from the user. And then we're going to have a relation with the user. So I'm just going to copy this relation here from the login token. And now we're going to get this error again. So we could either run npx Prisma format, or we can add this ourselves. So I'm just going to add it. So I'm going to say post is an array of posts. Now we can format this document. And we can run a Prisma migration. So npx Prisma migrate, and I'm going to call this migration add posts. Okay, so let's go back to our post router here. And for our create post mutation, we're going to have input of create post schema. Then we're going to have an async resolve. And for posts, let's also add our resolve. And let's do the same as well for single post. And for single post, we can also add our input. And this is going to be single post schema. So when we create a post, we want to make sure the user is logged in. And there's a couple of different ways we can do that depending on what sort of functionality we want. So the first way is we could say .middleware, and we could add some middleware to this route. And we could get async, and then we would have access to context. And then we could say if not context.user, then we would throw an error. The problem with this is we want logged out users to be able to view a single post and multiple posts. So we can remove this middleware here, and let's add this to the actual resolver itself. So I'm going to say if not context.user, then I want to return new tRPC dot, and we need to import star as tRPC from at tRPC/server. And this is going to be tRPC.tRPC error. The code is going to be forbidden. And then the message is going to be cannot create a post while logged out. So we need to get context out of our resolver here. And we can also get our input. So now that we've made sure we have a valid user, we can say const post is equal to await context.prisma.post.create. I'm going to pass in the data. Now I'm going to spread input. And we also want to connect a user. So I'm going to say user is equal to connect. And then the ID is going to be context.user.id. And then finally, we're just going to return the post. Okay, so getting multiple posts is really easy. We're going to return. We need to get context. Context prisma.post.findMany. And that's it. For getting a single post, we have input and we need context. So we're going to return context.prisma.post.findUnique, where the ID is equal to input.id. This is actually called post ID, not ID. And that's it. So let's go build out our UI for creating a post, listing out our posts, and getting a single post. So inside of Pages, I'm going to create a new folder. This is going to be called Posts. Then I'm going to create 3 files in here. The first one is going to be index.tsx. And this is going to be our listing page for our posts. Then we're going to have brackets post ID.tsx, and this is going to be the page for a single post. And then we're going to have new.tsx. So for new.tsx, we're going to define a function called create post page, export defaults, create post page. I'm going to say const is equal to use form, and this is going to come from reactive form again. We can define our generic here as create post input. Then we're going to get out our handle submit and our register. We're going to get our mutation. So I'm going to say const is equal to tRPC, which is going to come from utils tRPC dot use mutation. The mutation we want to use is post.createPost. We're going to get mutate and we're going to get error. Next, we want to define a onSubmit function. And this is going to take values, and the values are going to be of type createPostInput. Then we want to call mutate with our values. Then we want to return our form component. So I want to return form. OnSubmit is going to call handle submit. And then we're going to execute that with onSubmit. Then if we have an error, I want to render out the error. So I'm going to say error and error dot message. I'm going to have a H1 that just says create post. Then I want to have an input, and this input is just going to be for the title. So I'm going to say type is equal to text. The placeholder is just going to be your post title. Then we want to register the component with register, and its name is going to be title. Then I want to copy this, and I want a text area for the body. We don't have a type on that, and then the register is going to be body. Then I want to have a button, and this is just going to say create post. Let's add a couple of break tags here, just so it doesn't look too bad. So the last thing I want to do is when I finish creating a post, I want to redirect back to that post. So I want to say on success, I want to call router, and I need to create a router. I'm going to say const router is equal to use router. So router.push / posts / and then the data.id. And I don't want all of this. I just want one object, and I just want to get ID out, and then I want to redirect back to ID. So I have one error here, and it says property ID does not exist on tRPC error or post. So we come back to the router, we're returning our post here, but the issue is we're also returning when we throw an error. We don't need to do that. We come back here, then ID is going to exist on our post. Okay, let's go back to our UI. We can click create post. Let's add a title, my post. We're going to add a post body, click create. And we get an error here, too small, minimum of 10. String must be characters 10 long on path body. Okay, so let's add some more characters to our post. Cannot read property undefined of create. And the reason for this is because when we make changes to our schema, we need to restart our server. Let's try this again. And we get redirected, to post and our post ID, but we have an error because we don't actually have a page for our post ID. Let's create this. So function single post page export default single post page const router is equal to use router, and then we're going to use our router to get our post ID. So I'm going to say const post ID is equal to router dot query dot post ID as a string. Next, I want a query for the post. So I'm going to say const is equal to tRPC dot use query, our post dot single post. And then we have some arguments here as well. So post ID. Next, I want to get our data and is loading. And if is loading, let's just return a p loading post. Otherwise, I want to return a div with a h1 of data.title, and then a p with data.body. So we are getting these question marks added in for us because post could be null. So we could say if not data, return error, and this is going to come from next error. And then we're going to give this a status of 404. So if we don't have a post, then we're going to show a 404 page. Let's come back. We can refresh and we get our post here. Let's go to a post that doesn't exist. And we actually get a validation error because this is not a valid UUID. So let's change this to A. And now we get a 404 page when we have a valid UUID, but no post that matches that UUID. So the last thing to do is to build out our post listing page. So I'm going to say function post listing page, export default post listing page. And you can see as we go along with tRPC, just how fast you can now develop things once you've set up the backend. So I'm going to say const is equal to tRPC, which comes from utils.use query, posts.posts. We're going to get our data and is loading. If is loading, return p tag loading. Otherwise, I'm going to return a div, and I'm just going to map through my posts. I'm going to say data.map, and I'm going to have a post. Then I'm going to return an article tag, and this is going to have a key is equal to post.id. And you can see that post is fully typed because tRPC knows what post.post is going to return. So next we're going to have a p tag, and then this is going to be our post.title. Then we're going to have a link, which comes from next link. And this is going to say read posts, and we're going to have a href of /posts /post.id. Okay, so let's go to our posts page. You can see that we have a listing of posts here. So let's create a couple more. So post number 2. Paste this in a few times, create it. We go to our post page. Let's have a look at our listings. We should be able to click on one and we go to a single post. Click on number 2 and we go to the next post. So that is how to build an API with tRPC and Next.js. If you enjoyed this video, please make sure you leave a thumbs up and subscribe so you get notified whenever I release new videos. Thank you for watching, and I'll see you in the next one.